Okay, so the next thing we're going to look at is how to solve logarithmic equations. Okay, so the biggest thing when you're solving log equations is to remember that if I've got something like log base b of m equals c or whatever, the biggest thing, and we did this in the last section, is that m has to be greater than 0. Remember, not greater than or equal to, but strictly greater than 0. That's because you can't take a log of 0 or a negative number. So essentially what we're going to do in our strategy for solving these problems is we are going to usually simplify one side to a single log using our, compressing product rule, quotient rule, power rule thing that we did last time. Simplify to a single log, then we'll usually write it as an exponent. And then once you've got it in form of an exponent, you can go ahead and solve for x, but you have to check it. So we want to make sure that whatever answer we get, that looks like cheek, whatever answer we get meets this requirement. So in the original statement, whatever answer we get, it has to meet this m is greater than 0 thing. Okay, so you could have a problem that looks something like this. So say you've got something like log base 4 of x plus 3 equals 2. I think my house alarm is about to go off. It might be really loud. Alright, we're going to rewrite this. It's already simplified as one single log, so we're going to rewrite it as an exponent. 4 squared is x plus 3, or 16 equals x plus 3. Do my thing, subtract 3 from both sides, and get x equals 13. Can I dance? Can I celebrate? No, I have to go check. I have to make sure that if I plug in x plus 3, oops, I already did it in my head, x plus 3, that has to be greater than 0. So I go 13 plus 3, is that greater than 0? Yep, so I'm good, and that's my answer. So that's good, that's like a fast problem, right? Okay, so let's try another one. So we've got something along the lines of 3 natural log of 2x equals 12. Okay, so like we said, we want to write this as a single log. So let's divide both sides by 3. We've got natural log of 2x is equal to 4. Remember, that's secret base is e. So I've got e to the 4th equals 2x. So I can now solve for x by dividing both sides by 2. So I've got x equals e to the 4th over 2. So then what we're going to do is we want to make sure that whatever our answer is, oops, I'm going to change my colors. We want to make sure that whatever this answer is, okay, so if we go plug this in, sorry I got distracted, we plug this in, we want to make sure that 2x is going to be greater than 0. So it's going to be greater than 0, so if we plug it in, we've got 2 times e to the 4th over 2. Is that going to be greater than 0? Oh yeah, these will cancel out. E to the 4th, that's greater than 0. If you don't believe me, you can always check, say, alright, my e to the 4, that's clearly going to be positive because e is positive, but, you know, sometimes your brain's not totally engaged, and that's alright. So if you want to check and make sure that 54 is clearly the greater than 0, so that works, and that's your answer. Now, of course, if I'm going too fast, definitely stop, pause, rewind, ask me questions. I'm always going to encourage you to please try to solve these problems ahead of me. So when I write this out, for example, if I write log of square root of x minus 3 equals 1, pause it. Go try to work this problem out so you can get it to work. This problem's actually kind of tricky because you're going to instinctively maybe want to do this, you know, and then pull it out front and, you know, kind of go nuts. But you don't want to do any of that, actually, because this is already written in the perfect format. You've already got something written as a perfect log. It's a single log. It's great. Just remember that it's log base 10 and go to town. Say, all right, let's convert this puppy. So 10 to the 1st is equal to the square root of x minus 3. So I've got square root of x minus 3. Square both sides. So we've got 100 equals x minus 3. Add 3 on both sides and get x is 103. As always, we want to check, we want to make sure that this is going to be greater than 0. So is this greater than 0? Let's check. Yes, that's going to be a square root of 100. That's clearly greater than 0. So that's a good answer. We've kind of lucked out, right? Every answer that we've gotten has been perfect. Okay. Try something like this then. Now we'll start to get into the funsies. Log base 2 of x plus log base 2 of x minus 7, and we'll set that equal to 3. So the first step is always you want to write this as a single log. So we're going to use the, what are we going to use? We're going to use the product rule. So we've got x minus 7. Now we have it as a single log, so let's write it as an exponent. Actually, before I do that, let me go ahead and simplify the inside of that, because that's actually kind of unattractive. We'll do that. Now I can rewrite it as an exponent. 2 to the 3 equals x squared minus 7x. So maybe you can see where this is going. Dum-de-doo-de-doo. And look what we snuck up on you. We sneaked in, whatever. We figured in a quadratic equation. Look at it, isn't it pretty? Alright, so how do we solve a quadratic equation? Well, we hope that we can do it by factoring. So I've got x, one of these is a plus, one of these is a minus. Got a minus 8 plus 1. So that and that. So x is negative 1 or x is 8. Can we dance? We can if we want to, but not really. That's just a song. We want to make sure that x is greater than 1 and x minus 7 is greater than 1. I mean 0, sorry. X is greater than 0 and x minus 7 is greater than 0. We need x is greater than 0 and x minus 7 is greater than 0. So if we stick in negative 1 here, is negative 1 greater than 0? No! So that means we threw out that entire solution. Alright, so let's test it. So I was testing it for x equals negative 1. Let's test it for x equals 8. We plug it in, x greater than 0. Yes. We plug it in here. 8 minus 7 greater than 0. Yes. So that's our only solution out of the two different options.